My name is Morgan Sawicki. I work with the Creative Services Department at Pikes Peak Library District, and this year we're working with Cool Science to celebrate making with All Pikes Peak Makes. So we had earlier this week, we did a panel discussion on making during COVID-19, which will be up on our YouTube channel soon. And today we are talking to some people who are experts in the area of robotics. So we're going to take a few minutes for everyone to introduce themselves and show off some of their stuff, share some cool things with us, and then we will start asking questions. We have some questions to ask the panelists, but I want to encourage you audience members to also ask questions. You can do that by, if you bring your mouse down toward the bottom of the screen for Zoom, there's a little button that says Q&A. And if you click on that, you'll be able to put in any questions that you have. And when other people put in questions, if you see questions that you like, you can click the little thumbs up icon underneath those to upvote them and encourage the panelists to answer them, or rather encourage me to ask the panelists those questions. So yeah, I'll be moderating this. You can talk to each other with the chat feature. Remember, if you want everyone to be able to see your chat, including the other attendees, you can click that to drop down in the chat box and change that to be all panelists and attendees. Otherwise, the only people who will see your chat will be the panelists. So with that said, let's have people start introducing themselves. So I guess we'll start with Jeff Gagne. Go ahead, take a few minutes and tell us about yourself.
Thanks, Morgan. Thank you, everybody. I am Jeff Gagne. I'm the creator of Zach and Zoe Adventures, which is a kids space and STEM brand, and I run it with my 9-year-old daughter, Zoe. She is the Zoe and Zach and Zoe Adventures. Over my shoulder here, you can see we have 3 children's books so far, which is the Zach and Zoe Adventures series. And over this shoulder, it's harder to see because they're sideways, but Zoe and I also create a monthly magazine called STEM to Bloom, which is the only children's space and STEM magazine in the world that I know of. That is all space and STEM all the time. So she and I create that. This one is actually an issue we did about robots and robotics and kids. So obviously that was a good one to pull out today. She and I do a lot of work. She actually had a live earlier this morning all by herself making a slime on the Colorado Springs, the Cool Science Festival's lab YouTube channel. So that's who I am, that's what we do, and going to be talking all about robots for kids.
Very cool. Yeah, so next, Lynn Sim, do you want to talk a little bit about yourself and your role with robotics?
Define a little bit, okay? So anyway, thanks,
Take
Morgan.
a few minutes.
My name is Lynn Sim. I am currently the chair for the Robotics and Automation Department at Pikes Peak Community College, down the Centennial campus down by Fort Carson. Retired Air Force, spent another career as a software engineer, and then started volunteering at the 21C, doing some of their programs, running their circuits lab and doing some classes for them. And that actually wound up getting me this job as the chairman for the robotics department down here. So that was very cool. Thank you, PPLD. But you can see over my shoulders some of the robotics equipment we have here. I'm in the lab at the school, and we have over my left shoulder here, we have 5 robots that are like that one. Here's another one right here. In the background farther, we have 2 heavier industrial type robotic arms. I brought in a couple of my friends too. This is a little It's called a penguin bot. And another guy that he can roll around and you can control him with your phone. Something that I did a class, it was called Teen College here at the college, and we had them build this, it's called a Me arm. And they control it with a gamepad type thing that we built. But there's a lot of these kits that are available out there. So I don't teach kids, I teach students, but they, probably the average age is somewhere around 35 plus, thereabouts. And hopefully we give them a skill set that they can go out in industry and play around with electronics and robots. That's what I am, or who I am, or something.
Very cool. Thank you for sharing that, Lynn. And finally, we will have Jeanette, Briton, and Mike Hinkle introduce themselves and talk a little bit about what they do with robotics.
I'll go first.
Okay, sure. I'm Jeanette, Jeanette Briton. We are a duo. We started off and brought an organization called Techno Chaos to Colorado from Texas. We had a robotics center makerspace in the Houston area for 5 years, where we taught K through 12 and also adults a lot of things like robotics, 3D printing and programming, Minecraft, kind of pull in the kids with the Minecraft and modding it. So we had a lot of fun with that, but we got kind of burnt out and we decided to have some fun. We tried to retire by coming up here to Colorado. We couldn't do that, didn't succeed. So I think actually our summer we moved, we were competing in the Sparks Funds AVC, if I remember right, if that was the right summer.
Yeah, it was our first year.
And we competed in actually you have a picture of it, right?
Yeah, I
you're,
do.
You're welcome to show the pictures.
We can show a bunch of pictures later.
But we competed in one, since we knew we were moving, we competed in one event that summer when we were moving. And then the following summer, we competed in 3 different competitions of their categories and won quite a few of them. But we do things, so for myself, we are a duo. He has a lot of the hardware and electronics capability. I do a lot of the software and AI capabilities. I've done autonomous drones kind of challenges with Lockheed Martin. And I'm trying to personally, we have about 500,000 Legos that we had from the makerspace that we had. So we are trying to sell those, and in some cases we use them for events or something, but in most cases we're trying to sell them, so I'm having to sort them. So I'm very envious of Lynn's robotic arm there. I'm using a Cartesian type robot right now model, but I'm hoping to move it and teach some of the high schoolers under monumental impact some of the techniques with an arm or a XYZ kind of CNC Cartesian model. I'll let Mike sure has plenty to talk about.
Hi, everyone. I'm Mike Hinkle. We are husband and wife, more than just a duo. But yeah, we are definitely partners in crime in this. I did my career in technology and IT architecture. But about 20 years ago, my interests in mechanisms and in modeling got captured by a documentary I saw on PBS about the first robotics competition. So I jumped very rapidly from that while we were still living in Houston into being a mentor and coach in that high school level competition, which is a fantastic engineering development program. I was pretty confident of my intelligence and capabilities and found out quickly how woefully lacking they were in the field of robotics. And so ever since then, I have just been totally, like I said, my mind and imagination have been captured by the potential in this field. Part of that is to be the best coach and mentor I can be. So when Jeanette said we failed at retiring, a lot of it is around the fact that we're both essentially coaching a high school robotics team, which is immensely fulfilling, but it keeps us very busy. But frankly, a lot of the skill development branched off into hobbies for me. So I treat the robotics hobby as a tremendous learning opportunity for me for multiple things. One, I love to keep current on technology, and as we'll probably discuss through this session, a lot of the most advanced and powerful technology is being channeled through robotics now, and I expect to see that continue. We can talk more about that later if that's of interest. But another one is to keep the mind fresh. I'm not a spring chicken anymore. I love to be able to maintain my ability to create and make. So that's where a lot of the hobbyist pursuits come out of. I make robots all the way from 150-gram robots that are half the size of my hand that actually do battle to right now we're working on something much, much bigger and meaner than that, to robot platforms for intelligence. We actually have some examples of that we can show some pictures of if that's of interest. So it's really fascinating. We do keep very busy, but we enjoy it and have a lot of fun at the same time. It's and that's one of the reasons why we recommend robotics, at least as a hobby, to other people and encourage them to get involved.
What a way to retire, huh?
Indeed.
Also, that's a lot of Legos. Holy cow.
Yes, it is.
Those are mine.
Yeah,
those are mine, not his.
Those are her Legos in my workshop.
No. This is your
Okay.
my workshop.
Okay. Calming it down here. I want to once again tell all of the attendees that you are more than welcome to put questions into the Q&A feature and we will answer them for you. I won't because I don't know anything about robotics. So I'm just as excited to hear what everyone is going to say as all of you are. So let's start with some really basic questions. How would you define the term robotics? What does it mean? And any of you can answer. Jump right in.
I'll jump in and give my easiest, simplest answer. A robot is a machine. It can have different levels of movement and control. The main thing that differentiates it from the regular machine is mobility is usually an element of a robot. Or we call it degrees of freedom. That's the number of different ways that it can move under, it used to be in the good old days, it was all manual control, much like a robot, that robotic arm, that purple thing that Lynn showed a couple of minutes ago. More and more it's becoming automated, driven by a program, driven by sensors. But that's what differentiates robots from normal machines. So I'm used to building robots that can move around and go do some set of tasks in different places. But even those robot arms there behind Lynn have all that different movement and the ability to do flexible kind of work. That's what I see as characteristics of robots.
If I can add to that, there's kind of a distinction between what I feel is automation versus robotics. And automation can be anything that doesn't require mechanics, and it can require mechanics. I mean, not require, but there can be mechanics. So automation can be behind the scenes digital and without anything mechanical, versus robotics. When you say robotics, you're typically talking about something physical changing, something physically moving, is my impression. So.
Jeanette, we really need to talk offline. So what I teach my students as far as the official definition of what a robot is that it has to be a machine, it has to be reprogrammable, it has to have a multifunction manipulator, and it has to be flexible, can perform a variety of operations. A manipulator can take the form of many different forms. For example, Mike's battle bots that he builds, the wheels and the other things that he has on there, those are all being manipulated by the onboard smarts of the platform. So it's, and sometimes the line between automation and robotics gets a little blurred, but there is a definite difference. We have a few what we call mechatronic stations here in the lab that are not robotic, but they're definitely automation. We do have a robotic arm that's integrated into one of the stations, but anyway, so that's what we teach the students as far as what robot is.
I would even say that robotics is venturing in, of course, to AI and data science. So there's a lot of collection of data that's happening now. So it's even more on the tech side that's coming out as industries like manufacturing add things to them. As a hobbyist, you don't get into that as much because you're probably more wanting to automate something to, you know, track and chase your cats or something. That's something I am working on. You know, but you might not get into that data science unless, as a hobbyist, you're trying to say how many times your cat is eating food or something like that. So you might add some data science to it.
I think that if we pull back a little bit farther, maybe like about a 30,000 foot view and take a look at robotics as a whole, it incorporates a lot of different disciplines.
Yep.
There's machining, there's 3D printing, there's hydraulics, there's pneumatics, there's electronics, there's motors, there's all the data science that goes behind. How do you get this arm to move to make it do what you want it to do when you don't have the remote control in your hand? How does it interact with the environment around it? The science of sensors, as Mike mentioned also, that they're becoming much more sophisticated and capable of doing, well, sensor doesn't do anything but of registering the environment, registering something and passing that information back.
Right, and I was just going to add that with what Jeff and his daughter's doing, that it's the STEM. So robotics covers all areas of STEM. So it's not just one thing that you have to understand sometimes. And sometimes that requires a team. So, you know, in getting support. So, you know, I definitely recommend reaching out to different groups or maker spaces in your area, Library 21C, and seeing who you connect with and see if it has a different skill set than you.
Excellent. I think we could broaden that just a little bit more from STEM, which I totally agree with, but also add in STEAM, which adds the artistic element in there as well. So,
yep.
We love arts in the library. Do you have anything to add, Jeff?
Just a simple definition that I give for kids. Robotics and robots are the combination of computers and engineering. So like Lynn was saying, it needs to be a machine. So the way I describe it to young kids when they're asking, like, is this a robot? Is that a robot? Well, mom's minivan is a machine. It's a car. It needs the human being. But a fully self-driving Tesla that doesn't need the human to drive it is a robot, and they get it right away.
Very interesting. Yeah, my next question was going to be directed to you, Jeff, which was, how would you explain the field of robotics to someone who doesn't know anything about it? Or as I like to say, how would you explain this to a 5-year-old? So that's great. You answered that. Does anyone else have like a really simplistic definition or anything? Like, how would the rest of you explain this to someone who is just completely in the dark about it?
It's a lot of fun. You know, generally, again, from our experience, like Jeanette mentioned, we had our own makerspace that was STEM education focused, and generally we would just show students. And you know, very young students, it's really interesting how they can bring their Lego building, tinkering mindset very quickly into this area. And it's a natural extension, highly integrated with what they're interested in already. So, you know, it's not until later when the machines get more complex and more serious that it actually seems to branch away into more of a specialization. But it's they're in the imagine space of playing with stuff that does real things. It's right in there for young people. And
Actually, Mike has a good example that we always brought to places to show what a robot is.
well, what a robot can be. Can I share the screen? And
Yeah,
you're
go
gonna
ahead.
see something really messy because I'm gonna show my whole screen just so I can get around to some things pretty quickly. But this is a robot. Okay, this is a real robot that we built. I don't have the construction pictures for this particular robot, but I do for its partner in crime that I can show a little bit later. But this is a real robot that we ran by remote control out in the public. So here's a picture of Jeanette driving it out on the streets of Sugarland, which is a suburb in the Houston area. And you can see her there in the green t-shirt. And what she's holding in her hand is a small, inconspicuous remote control. But this was a robot because of the way it moved and the kind of actions that it performed. So the head would move, the leggy things, if you're familiar with how a Minecraft creeper should move, the leggy things moved and such. And we eventually updated this to have a speaker system and a video system in it when we wanted to be a little bit less obvious what we were doing. But that's an example of a robot. And again, the reason we built stuff like this was to give people, especially young people, a very clear example of what they could do, the kind of fun they could have, and you know, how, you know, the representations this could have in their lives with robots. So this is the creeper's partner in crime. So everybody knows this is the Minecraft creeper. This is a sorry, I'm going to probably be getting all kinds of distractions here. That's the downside of sharing the whole screen. But anyway, this is one of the more fun things that we did in getting the message out and giving good examples was here we're lined up to participate in the Houston Art Car Parade. So we actually drove these robots. This is Jeanette and our two boys back here in a golf car that we converted into a minecart. So you know, we drove these over 3 to 4 miles of Houston city streets, which are some of the worst streets in the world. I mean, as far as condition. And, you know, so like 100,000 people would see them at one time. It was kind of cool. But these are both robots in the way they act and the things that they represent. So it's just a quick share to give people some ideas.
Cool. Thank you for sharing. We do have an audience question, and this came in when we were talking about automation, I think. And John would like to know, so would you say an algorithm to play the game Go is not a robot?
My take on that would be, no, it's not a robot because it's not a machine, it's an algorithm. Now, if you incorporated that algorithm into something that had a mechanical manipulator, a gripper, so that now you're having the robot play a physical game of Go, yes, now we have a robot.
I would agree with that, Lynn. And so it typically a robot requires the interaction with your real space, okay, the real environment. And what you just described was you're automating something. So you're digitally automating something within a digital environment. So it's an automation. Nothing wrong with that. And that's fun. That's what I do. He does more of the physical stuff, but I'm more of that AI stuff and digital stuff. So.
You know, in technology, we frequently refer to software entities as robots. It depends on their kind of actions and how they interact with the rest of the system. But realistically, we are focusing on machines, something that has a machine element.
And some people would say the computer is a machine, but that's not, you know, it's you need the computer to actually run it, the CPU and so forth, the board. And that wouldn't, it's kind of negated, it's not counted. So.
Anything you want to add, Jeff?
Nope, they said what I was going to say. I agree. I think it's more of a program, not a robot.
Okay, great. So the next question, which is kind of big, that we would like to ask is, how have you seen robotics change over the past 10 to 20 years? And how has the perception of the field changed over the past 10 to 20 years?
Wow.
That is a
big one.
That's it. It has
you.
changed a lot. Jeff, go ahead. Go ahead.
I was going to say, I have a pretty good answer for this one, or at least I know what I want to say. So I'll give you guys a minute while I talk. My daughter is 9. So at that sort of 10-year mark, when I knew I was about to have a daughter and I was going to be a dad, a lot of it, because I'm an educator, a lot of my thoughts wrapped around how her education world was going to be different than mine. And it has been very much the same in some ways and wildly different in other ways. Very much the same. She goes to school. She goes to public school. She has a backpack. She has homework. She has all that stuff. However, especially with the COVID world that we're in right now and the end of last school year and starting this school year, she started virtually. So the fact that she had countless, and when I say countless, I mean I literally stopped counting how many different programs, applications, programs, apps, and recommendations for websites that have 35 of the best programs and apps that she could get: math, language, science, space information, as well as education help. The amount of technology that is in her education over the last 10 years has been amazing. And to bring this back to robots, just a couple of things aside from, you know, she's a kid, she has a tablet, it's right over by Fishy. One of her toys is a Sphero Spark Plus. It is one of a line of Sphero robots. These are very popular with kids. They are a little bit limited. Sphero, I love you, but there's only so much you can do with them. To the point of my daughter loves to 3D print things as well. We don't have one at home. I have access to one, so she likes to let me know what I should print. So what I see as the biggest difference is in the last 10 years for me is by the time I was 10, I was still wishing about having a robot. She has them. I was wishing that I would know how to build or get to use, you know, I still want a Jetsons flying car because that's when I grew up. And, you know, Tesla's getting close with a self-driving car. It's not off the ground, but, you know, you take what you can get as it comes. But I now start to see sort of the differences of how my dad saw my growing up versus how I'm seeing my Zoe grow up. And she has a lot more, you know, Roomba is a robot that vacuums your house. I didn't get that. That was a chore on my list.
And you can hack it now.
Yes. Yes, and you can make it into other things.
And that's another thing, yeah.
In his lab.
And
so that's the biggest difference I see in those 10 years.
And I'll expand on that. That was a great opening, Jeff. Is like there's a proliferation. There's a lot out there that you can get involved in, and you can see, and you can interact with. You know, like I just said, the Roomba you can now hack. You know, you can put ROS on top of it, robot operating system, and interact with it. Make your own thing as a stack on top of it. So a lot of things are, and some people might not like the word hack, but you know, you can adapt it. Okay, you can start to work with it. You see a lot of open software things going on. A lot of open hardware things are starting now, which means that everything is open, the infrastructure, the framework, and a lot of things that you can interact with. So, which is a good thing for students. I mean, if you are a hobbyist, you can get involved. I mean, you can work with these things. Another thing, I'll do a comparison. You did say 10 years. You can see we got a lot more gray hair here. But you know, when I'm an actual chemical engineer, by the way. So I used to work in lab automations. And so the comparison that I see now is that with robotics and kind of moving things back and forth, is before it was very big. The systems were big as far as how big they were in size, but they were also not open. So you would have to tailor your programming to that system. But then also they were more procedural. So you could only do certain things with them. And now you've got things like artificial intelligence, training things to do certain tasks and know how to adjust. Even in a simple hand pickup motion, which Lynn can probably speak to, you can actually teach it to how to do those things versus relying on how you coded it. It's more of how you're teaching it. So, and I don't know if Lynn, you want to expand on that, but.
How long do we have? Yeah, so things have changed a lot. Okay, that's the very short answer. Computing power has increased tremendously. Our software understanding of how to make a robot mimic human actions or get it to do something that we want it to do has changed tremendously and continues to change, continues to improve. Sensors are another area that has changed tremendously in the last 10, 20 years. They've gotten smarter. We now have, in the last 20 years, microcontrollers have really come into their own, both PIC and AVR architectures. And Arduino is, well, in my world, it's a very common word. But it's a microcontroller that lets you do a lot of things. And now you can attach that microcontroller to a sensor, and now you have a smart sensor that works, that can send better information back to the computer. The things that have changed over the last 20 years, yeah, it's almost the stuff of science fiction. What we can do now versus what we could do 20 years ago. Unfortunately, not everything has kept pace. We still have problems with batteries. We just need to get the energy density on batteries up higher so that they can store more energy and last longer. And that would make robotics a lot better. We have sent, you know, the Mars rovers that are out there, several of them out there that have lasted far longer than anybody thought they would. But they're doing things that, well, they were actually, some of those were probably started thinking about 20 years ago. But yeah, it's just, it's amazing how much has changed in the last 20. And I think the pace is only going to accelerate over the next 20.
Yeah, for me, a really good example of this, I echo the comments of everyone. I think a lot of this has been behind the scenes. It's not really sneak attack. It's just, I view it as most robotics is not really ready for direct interaction with humans. There's a variety of reasons for that, but really good at a lot of repeated, precise, mundane actions. So to me, one of the strongest examples of what's happened with robotics in the last 20 years is Amazon one-day delivery. Can you believe, I mean, I ordered a costume shirt for one of my boys today to wear to school on Monday, and it's gonna happen. And it's a weird thing. You can hardly find it anywhere. I could walk through every store in my area and not find it. but it's going to be on our doorstep tomorrow, and he's going to be able to wear it Monday. That would not happen without robotics on so many different levels.
And automation.
And automation. Yeah.
Great answers. Thank you, everyone. We have another attendee question. So this person is asking, is there a way to get into robotics if you don't have a background in engineering? For example, I'm a science teacher with a degree in liberal studies and environmental studies. Is there a demand for non-engineer majors in this field? And I would tack on to that, for people who are just getting into the field, or people who are vaguely interested in it, are there cost-effective ways to enter this world of robotics?
Yeah, I'll go ahead, Jeff.
Sorry about that, Mike. Actually, I'm going to reference the two of you. My first answer to that question is, one of the best ways that I've noticed is to become involved with a robotics club, whether it's college level, high school level, or even middle school level. And obviously, that level may depend on your comfort level in the level of robotics that they're doing. But like a high school level robotics club that Jeanette and Mike are involved in, you don't need to know everything, because there will be other mentors with you. So you get to both learn and mentor. And there are so many more students that want to participate that need more mentors and more assistance in that. That's where I would direct you first.
Right. Yeah, I actually think a person, who has the background of the questioner actually has a real competitive edge in this. And it's to build on a comment that Lynn made a while ago about STEAM. We frequently use the acronym STEM because it's more well known. And STEAM sounds familiar, sounds like something else that you know, and the acronym has nothing to do with that. Basically, it's the creative thinking, and that comes from an artistic approach. That is frequently the secret sauce to really good solutions. So you've got a creative, a right brain thinker who needs to get with engineers who frequently struggle with some of the creative aspects of projects. That can be a tremendous combination. So I really encourage, to use a recipe similar to what we did. Get into it as a hobby. You can ramp up very quickly there. That's another thing that has changed. 20 years ago, you search for robotics help and information on the internet. The internet was available then. There was not a whole lot. You had to search really hard. You still had to get plugged into communities to get much knowledge and capability. These days, there are plans and answers for everything out there. I will admit you do have to sift through some of it, because there are bad answers out there also. But there are tremendous answers. There are projects at all different skill levels, all different levels of expense. So get into it as a hobby, but this is also a fantastic reason to connect with maker spaces. I know that there are some constraints about that right now, as we're still in the time of COVID, but eventually that will change. And some maker spaces are doing some limited activities even now. So get involved. That's a fantastic thing about the time we're living in. You can literally learn by doing and build some very advanced knowledge and skills.
I would just add on that is that you definitely need to have a persistence that you're wanting to learn this, because like we said before, it covers so many different areas. So don't bite off more than you can chew. It's nothing wrong with taking a simple Lego kit that has some mechanics to it and just learning from that in a simple program that they have with their Mindstorm. Actually, it's EV3 right now, I guess, is their latest one. Yeah. My favorite kit is their We Do kit, that allows you to go to simple Scratch and do some simple programming and simple mechanics with the Lego We Do. So just find there are tons of kits out there. Just try not to stick to one, though, if you really are trying to branch out. And actually, we are a proponent of And everyone's different. We like challenges. So we actually compete in most cases to learn something new. We might not know what we need to do to be successful and win, but we get into those competitions like the Spark Fun ABC and so forth to just kind of challenge ourselves to learn it. And it gives us a deadline. And sometimes these challenges have forums that will help each other kind of go forward with that. So with that in mind, I'll just say that COVID kind of hit us this year, but last year we had something called a Gobble Squabble in the November timeframe that we kind of pulled together for high school students was our target, but we also had it open to adults. So it was basically a small combat bots, you know, like 3D printed combat. So you get design, you get electronics and so forth. And then on the AI side, we're thinking about adding a donkey car type capability, which there's a good forum for that for some of the, if you're trying to get into neural networks and a little bit of that kind of like, how do you train something to do something? So
I'd like to,
always open to suggestions too, but I'll let Lynn talk.
I'd like to piggyback on what Mike said, because I think it's really important, depending on your skill level or your interest level, get out there and get involved with the robotics club. I know District 20 is involved with FIRST, and I'm not sure about the other districts, but just get out there and get involved. And I see that the questioner has had some coding experience. That's a huge part of robotics. Without any coding, without any programming, you have a pile of metal. It's not going to do anything.
Right.
So if you have some software experience or helping students learn coding, huge step in the right direction. But just, you know, get involved. Check out your, a little plug for the college here. Check out your colleges, check out schools and see what kind of classes they might have that you're interested in to take, or even in all your infinite spare time, go out and volunteer and help them. But the more interaction you have, you learn. You can't help but learn.
Yeah, I'll also plug PPLD here and say that if you have a PPLD library card, you have access to lynda.com for free. So if you go to our homepage, ppld.org, you can search through the resources for lynda.com, log on, and there are just hundreds of different classes on coding and software that you can learn for free.
Cool.
If you all had to recommend one like pretty low price robotics kit for a beginner, which one would you recommend?
For me, it would be the Lego We Do, actually. So, I mean, because you got basic bricks, you know, you're not fumbling with the different components to make manipulation happen. And it has a simple coding block, and it also, you can use either their own platform or there are expansions off of that to either do Java, Scratch, or other kind of programs. So if you're really a starter beginner, I would recommend that.
Yeah, using what's called the Technic style Legos, which are different than what you typically get in a kit, you know, that you buy from Lego. But there's certainly ways to acquire them. You can build any kind of machine you can imagine. And then with the controls and motors like Jeanette is mentioning, you can add control and automation to this thing. So yeah, Legos are a very powerful building kit. I'm not sure I'd really call them cheap anymore, but you know, they're definitely affordable. I think as far as cheap, you know, in all honesty, there are some very good inexpensive kits available out there from the big online vendors. Again, I already mentioned them once, I'll mention them again. I'm not an employer or anything like that, but on Amazon, there are some great Arduino based robotics kits. And I really recommend that people start with something like that and not just an all remote control kit. You know, the remote control makes it really easy to get in an immediate burst of fun, but you really can't do a whole lot beyond that. to get into the programmatic aspect of robots. And that's what the future is all about. You need to have something programmable on it. And the Arduino board is an excellent and way more capable board than most people really recognize. And you can get a good kit. At Technical Chaos, we started using the kits by Make Block because they had good quality, but they were very cost effective. Those are still available. There's some other kits out there that are available for even less. Talking about Colorado vendors, we've already talked about some of them like Sphero, but SparkFun, again, going back to them, they've got a really cost-effective, under $100 Arduino robot kit with a nice little set of sensors in it. You can do all kinds of projects that involve sensing and robotic control. Plus, you can do remote control with that kit. All of those are that I mentioned. The Arduino-based stuff is under $100 and definitely worthwhile.
So I'm going to talk about Arduino kits. That's my favorite word, is Arduino. But so I've got this little guy. He's a Penguin bot,
right,
but he's Arduino based.
Yep.
And he's got several sensors on it. You can make him walk and dance, and there's even sound that you can do with him. And this guy runs for about $40.
Yep.
I have a couple of others that are. This is a microbit,
right?
Micro::bit, but it has. This is the actual card for it, and this is the car chassis that you can attach it to, and it has several sensors built into it that you can program. There's also things like this that it's a lot tougher to program. They've got some built-in commands, and if you just want to play with something, then you could go that route. But like Mike was saying, I think the biggest thing, not the biggest thing, but an important thing is that if you want to get involved with robotics, find something that you can program, that you can experiment with. Don't just take it as it comes. That's what my dad always told me. He says, yeah, what you buy is great, but see if you can make it better. Look at it, see if you can make it better, which he probably wished he hadn't said, because there was a number of times I tore things apart to see how they worked and make them better, and they didn't always go back together again. But
yeah,
so there are a number of kits. I just went out and looked. You can get an Arduino kit for about $30. That it's more, that particular kit is good for automation type. But then you can also get chassis that have motors that will take the Arduino, and you can program that car to run around the floor, avoid obstacles, follow you, light up lights. It's a lot. There's a lot of things you can do with it.
So to put the family spin on this, and this will be quick and easy, I completely agree with what they've said. And the way I tell families about how do I get my 6-year-old or my 9-year-old into robotics, what should I get them? I tell them it's a lot like shopping. Do you buy name brand of everything, or do you now buy some great value stuff from Walmart or Kirkland brand stuff, because it's either just as good or better and cheaper? Lots of family knows Sphero. So this is $60 and they're like, oh, I got my kid a Sphero. It's very limiting. All it can do is roll around the floor. Sphero now has an upgraded model called an RVR. But the upgraded model that has tracks and a board that you can actually program and start to modify is $250. And then Lego, while they do have the We Do kit, lots of people hear about the EV3 bricks and they're like, oh, I want to get my kid one of those because you can build anything out of. Yeah, that's a $400 kit. So if you can afford those, great. But I try to tell my families it's a lot like shopping. You're paying for that name brand of Sphero or Lego that you know, where you can get every bit as much of the robotics with an Arduino kit that our panelists just talk about for a lot less money. And even though I use these with my kids and my classes, you get a lot more robotics learning out of the Arduino kits because you have to put more into it. Lego and Sphero didn't do the work for you. So you're learning from the very start. You're building it exactly like Lynn said. And you end up further into robotics after 6 months of having an Arduino kit than you do with a Sphero or a Lego kit.
Morgan, let me just wrap that up and say that every kit is going to depend upon the level of the individual that wants to apply it. And so you have to look at that when you're purchasing something. And so, for me, an Arduino might be too much when I first started, but I could start with the Lego at first, or some lower end of the Lego, and then working into it. So it all depends upon the individual and where they are and what they're trying to learn, actually. So
one further comment, if I might, is that we could do this all afternoon. Is that with the Arduino, one of the reasons that we keep mentioning Arduino is it's one of, if not the most popular microcontroller out there. There is such a huge user base out there online. There's a lot of tutorials. If you want to do anything with an Arduino, you Google it, and more likely somebody has already done it and written something up. Instructables.com is a great place to learn how to build things with Arduinos or whatever else. Anyway, so get something and then go Google it and figure out how to find a tutorial and work with it.
Or join a club and rotate the equipment around each other.
That was very helpful. Thank you all. We have been rushing through this and we have 5 minutes left. So I'm gonna close this out with another kind of big question, and hopefully we can try to keep the snippets very short, short snippets of answers. I'm gonna try to combine a few of our questions here. So what are some of the pros and cons of the growth of robotics in society in terms of like AI and the workforce? And then should we be legitimately worried about robotics taking over as overlords? What do you have to say about that?
Jeff?
Yeah.
I think the increase, just like Lynn was saying earlier, that the next 10 years, 10, 20 years is going to be a rapid growth compared to the last 10, 20 years. I think it's a great thing. Progress works really well. We figure out how to make it work. And to answer that big question of are we going to have AI robotic overlords? I am not in any way concerned about that. I've listened to, Elon Musk is kind of right at the front of telling everybody we should worry about it. And it's so much closer than you think. And he's just going to implant a quarter-size chip in the back of everybody's neck and connect it to your brain. Well, as somebody who almost got an internal defibrillator put in, and knowing how long we've had those and how many problems they still have connecting two wires to your heart just to make it go and not fritz out and kill you, to what he's talking about for attaching a computer to your brain permanently, we are nowhere close. We're 1,000 years from that.
I was going to say that unfortunately, the progress and how fast it's going, it's leaving the workforce behind. They're having problems in things like manufacturing with even supporting some of the automation techniques that are going on and finding the resources. So if you're interested in this kind of stuff, definitely reach out to your local colleges, or even just start tinkering and getting those skill sets, and go into challenges, competitions, to at least show off your expertise. Because I do think that it's going to continue this progression of progress. And hopefully you have a heart that you're wanting to learn. It's a journey of always learning, because in this field you have to be that way, because it is progressing.
I think there's a couple of mindsets that need to be changed. One is the average worker bee mindset, who fears the robotics because it's going to take their job away from them. The other mindset is that of the corporate mindset. They want to bring robotics in to be more efficient. Robots don't need to take lunch breaks or vacation time. And so they're constantly, it's not that robots are faster than humans necessarily, but robots are more consistent. They're constantly working once you get all the bugs worked out. And so those two mindsets need to be changed. The worker or the corporation needs to be willing to retrain their workers, because when the robotic arm or robotic or automation piece comes onto the production floor, it actually creates new jobs in order to be able to have them functioning properly. But the corporation needs to be willing to retrain those people they've already got to handle the new jobs that have come along. And the workers, like I said, they need to understand that, okay, we've got to change skill sets. And so that I can be, times are changing. There's nothing that's going to stop that. And if the worker doesn't want to or can't, for whatever reason, update his skill sets, then there's an issue. But there are so many new jobs created. I was looking through here, doing a list of some of them. There's design, programming, subsystems consisting of hydraulics, pneumatics, electronics, motors. There's machining, there's 3D printing, there's assembly, there's maintenance and repair. And that's just ones that I can think of off the top of my head. So as far as the AI, as far as a real version of iRobot, no, I agree with Jeff. I think we're a ways away. Our software is not smart enough. We're not smart enough yet to make the software smart enough to be able to do that. Yeah, at least.
Yeah, if I could jump in real quick, I promise to be brief, and hopefully this doesn't get cut at the end of the hour. But I view it is a big transition. It's a revolution level transition. I would compare it to the advent of the Industrial Revolution in this country, the transition away from agricultural to other economic and job bases in the country, and the PC revolution. I have been around long enough to see that change firsthand, and as a professional to go from tremendous frustration knowing that I needed to depend on all these other people in some defined process that could not be changed in order to even get minute things done, to where these days I can do tremendous things with tremendous creativity very rapidly. So, we're going through that kind of a change. And will there be winners and losers? Absolutely. But I would ask, which one of those revolutions that I cited would I want to undo? And the answer is clearly none. I like where we are, and I think the future has lots of potential. And on the other thing, robot overlords, in all honesty, if AI is going to take over, it doesn't need robots. So I see those as totally separate things, and I'm not worried about either.
Well, you've all made me feel a lot better about the future of the world. Does anyone have any closing remarks before we say goodbye?
Robots are cool.
Robots are fun.
More people should get into robots.
Yep. And life is a journey of learning.
Very true. Very true. Well,
Don't be afraid. Don't be afraid of robots. I mean, by that I mean, people think robots and think it's something that's really technical and it does all this stuff. If you think it's cool, then like I keep telling my students, how do you eat an elephant? One bite at a time. So
don't eat any elephants, though.
No.
Disclaimer.
Don't eat any
disclaimer.
robots either because they're too crunchy. But just get into it. Take little pieces at a time. Don't get into it expecting, oh, by the end of next week, I'm going to know everything there is about robotics.
And reach out to get help. I mean, if you really want to learn it, there's a lot of opportunities here in the Pikes Peak region, especially with the library.
Go to the Pikes Peak Library District.
Yep.
Oh, thank you, everyone. This has been really, really enjoyable and lovely. And I want to thank you all so much for giving your time to this panel and giving us your knowledge and expertise.
All right.
Yeah.
Been
Most
a blast.
welcome.
Thank you, Morgan.
Thank
Thank
you
you.
so much.
Yes. Thanks,
We'll
Morgan.
Talk to you all later.
Off my hand.
Excellent. Bye, everyone.
Bye.
Bye,
Bye.
everybody.
Listen, they want us-
Lynn,